All right, so now we're going to talk about absolute value inequalities involving greater than, or the greater than or equal to. The inequality absolute value of x is greater than 3 means that the distance between 0 and 3 is greater, x and 0 is greater than 3. So you would have to go out 3 steps either way, and then anything beyond that would work. Okay, so notice these regions don't overlap, so this is a or statement. So x is less than -3 or x is greater than 3. So as long as you do either of the two, you're okay, right? So there may or may not be an overlapping region with the greater than inequalities. So just like the previous example, you have to consider both cases. The expression inside the absolute value is non-negative, so x is greater than 3, or the expression inside the absolute value symbols is negative, so x is less than -3. So let's solve 3n, absolute value 3n plus 6 is greater than or equal to 12. Then graph it. So case 1, you do 3n plus 6 is greater than or equal to 12. Or case 2, 3n plus 6 is less than or equal to -12. Both cases, you're going to have to subtract 6 from both sides. And then divide both sides by 3. So we didn't write that here, but divide both sides by 3 here and here. So I would get n is greater than or equal to 2, or n is less than or equal to -6. You have to use an or statement. You wouldn't write n. You don't write it as one single statement like you can do with the and. You wouldn't do n is greater than or equal to 2 and less than or equal to -6. Just don't do that. An or statement, you always have to write it as two separate ones. All right? So as long as n is greater than or equal to 2, so you close circle on 2, shade to the right, and n is less than or equal to -6, close circle on -6, shade to the left. And that's our solution set. All right, here's 2 for you to try. Go ahead and pause the video. Okay, we're back. So let's check it out. 2k plus 1 is greater than 7. So case 1, 2k plus 1 is greater than 7. And 2k plus 1, case 2 is -7. So you flip the inequality symbol. So subtract 1 from both sides on each one. You get 2k is greater than 6. 2k is less than -8. Divide both sides by 2 on each case. Here you get k is greater than 3. K is less than -4. Now notice, we got to graph these now. So k is greater than 3. So here's 3. So that's everything up here. Remember, this is an or statement. And then -4 would be somewhere down here. So put a circle, shade everything down here. So the solution set is k such that k is less than -4 or k is greater than 3. Okie dokie. Now, this one, remember how when it was less than, you can never be less than a negative number. Well, absolute value is either the lowest the absolute value could ever be of a number is 0. Okay? Because if it's not 0, if you have a negative number and you take the absolute value of it, it flips it to be a positive. If it's a positive number and you take the absolute value of it, it's still positive. So this is saying, when is the distance from r minus 6 greater than -5 from 0 on the number line? Well, that's always going to be true because all absolute values are either 0 or positive. In other words, they're non-negative. And all non-negative numbers, like 0 or any positives, are all greater than any negative number. So this would be all real numbers. Pretty cool. You really don't have to do any work from those. Okay, now I know there's 2 different ways with the absolute value. You could either get all real numbers or no solution. You just got to think about it. Here, this is saying, remember, this one's saying absolute value is bigger than a negative. That's always true. In the other case, this one was saying absolute value is less than a negative. That's never true. All right, so if you think about it like that, that might help you out a little bit. All right, guys, that's it for this section. Please continue on to your assignment and reach out to me as always if you have any questions, and you take care.